Dad body hammers. Right. He borrowed those as he had some suspension work to do. I better remember to ask him back for that before I put up my snow fence. Now, what was I supposed to be doing? Right. What we want to talk about today is figuring out the displacement of an engine. Another name for the displacement of the engine is the swept volume of the engine. So if I have a cylinder, there's my cylinder. In that cylinder I have a piston. That piston is traveling up and down. The distance from the top of the piston at top dead center to the top of the piston at bottom dead center, that volume inside the cylinder is my swept volume or my engine displacement. So let's do a quick example here. Let's say my piston, my cylinder, the diameter of the cylinder is 5.4 inches. And let's say when the piston's in the cylinder, piston at top dead center, piston at bottom dead center, the distance that that piston travels is 6.5 inches. Okay? So we need to figure out the volume. So there's some formulas that you need to know. Volume equals area times length. So what they mean by that, volume equals the area of the top of the piston, how much area the top of the piston covers. Length is the length that the piston travels, the stroke length of the engine. Okay, now we need to know how to figure out the area. Another formula, area equals pi r squared. So pi is a constant, 3.1416. R is the radius. The radius is from the center of the circle, the perfect center, to the outside edge of the circle. So in this case, we'd take 5.4 and divide it by 2, and that would equal 2.7 inches. Okay, so we'd go 3.1416 times 2.7 times 2.7, and that would give us our area. Then with our area, we just times it by the length of the stroke, 6.5, and that would give me volume. So if I type that out, I would end up with the volume of the cylinder. So let's just do that. 3.1416 times 2.7 times 2.7. I'm just going to equals that 22.9. So the area equals 22.9. This is inches times inches. So that's inches squared. Now we know the area. We know this. We can times it by the length. The length is 6.5 times 6.5 inches. So the volume equals 22.9 times 6.5. That is 148.9 inches. This is squared times another inch. So now it's inches to the 3 or cube power. So this engine is 148.9 cubic inches per cylinder. So if this happens to be a 6-cylinder engine, it has 6 cylinders, they're all the same size. I just take this number, times it by 6, equals 893 inches cubed. Total engine displacement. So it's an 893 cubic inch engine. There is another formula for figuring out the area that a lot of mechanics prefer. So we'll try to remember this number. I'm just going to write it over here, 893. Okay. There's another method defining area. Area, to make this simple, a lot of people remember how to find the area of a square. So let's just draw a square. Let's say this square is 5.4 inches wide and 5.4 inches tall. Okay, to find that area, I just go 5.4 times 5.4, and that's the area of that entire square. We need to find the area of a circle. That circle happens to fit in that square perfectly. Normally it would be round. So that means across here is 5.4. If I did a whole bunch of funky math and figured out the area of these little triangles around the outside, and figured out as a percentage, it would work out to that this plus this plus this plus this is about almost 3/4 of the area, or 1/4 of the area of the entire thing. So if it actually works out to that this area of the circle is just over 0.75%. It's actually 0.7854. This is 0.7854 of the whole thing. So all I got to do is take the length times the height. So 5.4 times 5.4 times that 0.7854. 5.4 times 5.4 times 0.7854 equals 22.9. This is inches times inches. So that's inches squared. So there's the area of the circle. Times it by the length, times 6.5 inch stroke, 148. So that is inches squared times another inch, so that'll be inches cubed. That number should look familiar. That's for one cylinder. Times it by the number of cylinders, times 6 equals 893 cubic inches. So you get the same number no matter which way you do it. A lot of mechanics like area equals diameter squared, so then they don't have to divide that, times 0.7854. This number here is the number of cubic inches that a 3406 cat engine is. 893 cubic inches is a 3406 cat. Let's do another one. Let's do a metric one. Because you may get metric, have to figure out in metric stuff. So let's do another engine. Whoop, there's the bore. The bore of this engine is 140 millimeters. So that's a diameter. Bore is diameter. Okay. The stroke of this engine, how far the piston travels, is 152 millimeters. Okay. So we'll do our formulas again. Volume equals area times length. Area of the circle times the length of the stroke. Area equals, we'll go diameter squared times 0.7854. So if I wrote this out, area equals the diameter, 140 times 140 times 0.7854. I'm going to end up with a great big number. 140 times, 140 times 140 times 0.7854. 14,504 something or others. So this is in millimeters, this is in millimeters, so this is millimeters squared. Okay? Now a millimeter squared is a very, very small piece of real estate. We're going to do this in metric. We're starting on a metric. So in an Imperial engine, we would measure it in cubic inches. With a metric engine, we can measure it in centimeters cubed, milliliters, or More likely in our industry, liters. Okay? So because we're talking probably more of our industry, let's shoot for liters, but we can do any of that. One thing you need to know, a cubic centimeter and a milliliter are samesies. These are the same things. So if I take a centimeter by a centimeter and I make it into a cube and I make it 1 centimeter tall, centimeter by a centimeter by a centimeter is 1 cubic centimeter. This is 1 milliliter. The number we came up with is in millimeters, not centimeters. So we need to change this from square millimeters. And if we timed this by the stroke of 152 millimeters, that's millimeters times millimeters times millimeters, so that's cubic millimeters. So I'll take our number and times that by 152. We end up with 2,204,608 millimeters cubed. Holy crap, that's a big number. If I look at my little square here, if I want to convert this to this, I know there's 10 millimeters going up, there's 10 millimeters going this way, and there's 10 millimeters going that way. So that is, I know there's 1,000 millimeters in every cubic centimeter, so I'd have to divide this by 1,000. So I'd end up with 2,204 centimeters cubed. That seems like the hard way to get about this. I know there's 10 millimeters in every centimeter. For my own personal thing, what I like to do is just take my millimeters right at the engine and convert them to centimeters. So I just move it over 1 decimal place. 1 decimal place. Now it's not millimeters, it's centimeters. Then I can run my formula. Now it's 14 times 14 times 0.7854 times 15.2, 15.2. 14 times 14 times 0.7854. That's the area of the piston, 154 centimeters squared. Times that by 15.2. There's the same number. For some reason, it isn't the same number. I typed something in wrong on the first time. 2,339 centimeters cubed. Now we have a thing. If this is also a 6-cylinder engine, we take this and times it by 6 for every, so we could take this and times it by 6. We end up with another big number. Myself, I like to keep the numbers small. There is, for 1 liter, let's try writing that little dyslexically, 1 liter equals 1,000 centimeters cubed, or 1,000 milliliters. So divide this number by 1,000. 1, 2, 3. So it ends up to be 2.34 liters. Times that by 6. 2.34 times 6 equals 14 liters. So this is a 14-liter engine. And this engine is actually the N14 Cummins 855 cubic inch 6-cylinder engine. So we did the 3406, and there is our 14-liter Cummins. So the metric is slightly more complex in all that usually when you're doing a metric engine, or an engine that they've converted to metric, like that 855 Cummins, where they converted it and called it the N14, is basically the same engine. They usually measure the bore and the stroke in millimeters. Biggest advice I can give you is change those two to centimeters, use the same formula, and you should be golden. So all we have to remember is 1 centimeter cubed equals 1 milliliter. 1,000 milliliters equals 1 liter. And you should be golden. Let's do one more, just for giggles. This one here. What I'd like you to do is figure out the displacement of this engine. This engine happens to be a 20 cylinder. The bore is 5.75 inches across. The stroke of the piston from top dead to bottom dead cylinder is also 5.75 inches. So let's see if you can figure out the displacement of that engine and maybe what type of engine it is. And we'll go from there. So just pause the video, leave it on the screen so you can see those two dimensions, do your math, and when you're done, fire back up and we'll see if we get the same answers. Okay, we need to know the volume of one cylinder. Volume equals area times length of stroke. Area equals 0.7854 times the diameter of the bore times the diameter of the bore. So area equals 0.7854 times 5.75 times 5.75, and that will give me a grand total of somewhere pretty close to 25 square inches. So 0.7854 times 5.75 times 5.75. That gives me 25.967. This happens to be inches times inches. So inches times inches equals inches twoed or squared. Now we know the area of the top of the piston. We times it by the length of the stroke times the area by 5.75 inches. So we go times 5.75. That gives me a grand total of 149.3 inches twoed times another inch equals inches threed, or cubic inches. 149 cubic inches for one cylinder. Times that by the number of cylinders. Times 20 equals 2,986 inches cubed. That's a lot of inches. Just shy of 3,000 cubic inches. This engine, what it is the 20V 149 Detroit. This is a 2-cycle engine, properly a 2-stroke engine for every cycle. 20 cylinders. It's in a V configuration. Boop. Okay, so 10 cylinders on one side, 10 on the other. It's 149 cubic inches per cylinder, and we found that out. There's the volume of the one cylinder. 149 cubic inches a cylinder. Okay. This engine was used in all sorts of applications. They made them in 12s, 16s. Oh, they made them in 8 cylinders, so you could have an 8V149, 12, 16, and the big 20. That one right there. This engine was mostly used in haul trucks, and top horsepower was 2,936 horsepower. So almost 1 horsepower for every cubic inch. That is pretty impressive. What else we got going on this thing? Pretty cool. This engine, the way it's built, and Detroit did this a lot with their 2-strokes, is it was a V6 block bolted to a V8 block, bolted to another V6 block. So it had 3 blocks all bolted together. It had 3 crankshafts all bolted together. It had 3 blowers, 6 turbochargers, and 3 intercoolers to cool the air to get that. Torque on this engine, I can't remember what the horsepower is at it. I'm going to guess somewhere around, I don't know, we'll say 1800 RPM, and torque is 4,000, approximately 600 foot-pounds at 1600. Crazy tire ripping torque coming off of this engine. Seems like a really big engine, but the engine really wasn't all that long. It didn't take up all that much room, and it only weighed 10,800 pounds. Incredibly light engine for those type of horsepower figures, and it would hold together at that. Amazing, amazing engines. Kind of neat thing about it, the 16 V149, that engine there was used in trains and stationary engines and boats and stuff, naturally aspirated, so no turbochargers, just the blowers, naturally aspirated with 600 horsepower. Well, 600 horsepower, that's pretty low horsepower numbers for an engine that big, but the thing we need to know about that is it put out 2,300 foot-pounds of torque. Not bad. And that wasn't even the 16, I'm sorry, that was a 12V. The 12V 149 put out that. Pretty amazing. Pretty amazing. Okay. 149 cubic inches works out to 2.4 liters per hole. So each cylinder is working out to 2.4 liters. In the turbocharged and intercooled versions, these put out, their maximum put out, I think if I remember, was 146 horsepower per hole. Pretty amazing. Pretty amazing. Pretty amazing engines. So these are obsolete now. Detroit quit making these quite a few years ago, and a company called MTU joined Detroit, or is part of Detroit, and they designed two engines, the 2000 series and the 4000 series, to replace these 149s. This is centimeters cubed, centimeters cubed. So this is 2 liters per hole, smaller than the 149, 4 liters per hole, quite a bit larger than the 149, to replace them. Yeah, pretty cool. Had nothing to do with the displacement, but hopefully it was interesting. So if anything, if you have any questions on the displacement of how to figure it out, just shoot me in the comments, or and I'll fix it or try to explain it a little better, and we'll go from there. Right on. Thanks for watching.